What do you want me to do? How do you want me to, this is a review session. I'm not gonna teach you anything new. I can use this time however you guys want me to. So I can answer questions, or I can come up with my own questions that might be useful. But you see how it's a better deal for you if you have questions. So don't be afraid to ask me anything as we go on. But if we don't have any questions, I'm just gonna go over what I think might be good for you. No guarantees. Good? Okay, yeah. Okay. Uh-huh. Okay, so this review we can use for the midterm if you'd like. So the Unit 2 test doesn't have dimensional analysis in it. We can still go over that. I'm not saying we won't, I'm just saying. So what's the Unit 2 test is due this weekend, right? And when I say due this weekend, is it really due this weekend? No, it's do it when you're ready for it. And if you say, oh good, then I have 3 months. No, okay? Get ready for it. And then, but don't do it if you're not ready for it. Unless you're just not gonna get ready for it. Okay, does that make sense? But I was thinking we will go over any questions you have for Unit 2 material. That's the chemical bonding. And then next week on Tuesday, we'll go over anything for the midterm, which is both Unit 1 and Unit 2. But we can still go over dimensional analysis if that's what you guys want to do. Your call. What? Is Unit 2 test says to, you want to go over that? Okay. Anybody else? I'm going to answer your question here, Eric. Is that okay to go over dimensional analysis for everybody? Is that okay? All right. All right, so if we have, let's say a doctor prescribed us to have 30 milligrams of a certain drug for every, can you see this okay? Is this big enough? Okay, Eric? Okay. 30 milligrams for every, let's say, 20 kilograms of body mass. Now, let's say we're a pharmacist, and, well, we're not given this drug in milligrams. We're given it in a solution so that they can inject it with a needle, right? So let's say this solution is for every 5 milliliters of this solution, there are 20, well, let's just say, I don't know, I'm just trying to come up with my own thing here. Let's say for every 5 milliliters of solution, there's, let's say, 10 milligrams of this drug. Good? So we want to know how many milliliters of this should we give our patient? Because as a pharmacist, we do not want to overdose them, and we also don't want to give them not enough because it's not going to do anything. So we use dimensional analysis to solve this problem. So first step in dimensional analysis is what? What is the question asking? With units, right? So what units are we looking for here? We want milliliters, right? How many milliliters of this solution should we inject in this patient every day or whatever, right? That's what we're looking for. The next step is, what do we know? If we don't know anything, we can't do anything, right? So we got to know what we know. This is given to us. 30 milligrams of this drug has to be given daily. And we're also given this. And we also have, well, it's not just 30 milligrams, it's 30 milligrams. I need to tell you something else too, don't I? 30 milligrams for every 20 kilograms of body mass. And let's say our patient weighs 140 pounds. So that's some more given information, right? You following? All right. Step 3 is start with what we know or don't know. Yeah, what we know. Makes sense, right? And we know 3 things here. We know that one, and this one. So now the question is, well, which one?
Don't we need to figure out what the difference between pounds and kilograms is?
Maybe. You want to start at 140 pounds? What's the right way to do it? The way that you think is the right way to do it. Okay? So don't think, oh, I don't know where to start, I don't know where to start. Just start. So Charlie said start at 140 pounds and find out how many kilograms that is. Because this says 30 milligrams per 20 kilograms of body mass, right? Okay, great. What do you think, Eric?
I think first we should convert the pounds to kilograms.
Okay, yeah, just like what, okay, perfect, let's do it. So we start with 140 pounds. And remember, if I want you to convert something from metric to standard American, I'm going to give you the conversion factor, okay? So for every 2.2 pounds is the same as 1 kilogram. So that goes away. Good? Making sense?
Mm-hmm. And since we have kilograms on the top and we know it's milligrams, or it's 30 milligrams to 20 kilograms, we should
Oh, yeah.
do milligrams next.
Can we rewrite this as 30 milligrams for every 20 kilograms?
Mm-hmm.
Can we also write it as 20 kilograms to every 30 milligrams?
Mm-hmm. 'Cause they are the
Which
same.
one should we use? The first one or the second one?
First,
Why?
It has kilogram, I'm sorry.
Go ahead. You see how the kilograms on bottom here? We don't want, do we want kilograms in our answer? No. So where do we want to put kilograms so that we can get rid of kilograms?
yeah, at the bottom.
On the bottom.
Cancel it out.
So we're going to put kilograms there, and we're going to put milligrams on top. So 30 milligrams for every 20 milligrams of body mass. And this is or mass, so they go away. Does that make sense so far?
Yeah.
What's your if you have any questions, let me know right now. No?
No.
Okay. So next, we have milligrams. Do we want milligrams in our answer?
No.
No, we want milliliters. Okay, we use that. We use that. We're not going to use them twice. The only thing we haven't used is that. So we don't want milligrams, so it better go down here. So that's 10 milligrams for every 5 milliliters. Milligrams goes away, and we're left with milliliters on top. Is that what we're looking for?
Yes?
And everything else goes away? So we did it right. That's how we know we did it right. What if, instead, we ended up flipping this thing somehow? To get the units to cancel, we flipped it. And milliliters is on bottom. Then what do we do?
Do all the same things still cancel?
Yeah, everything cancels. Let's say everything cancels, but the milliliters ended up on bottom instead. They didn't here, but let's say it did. Then what? Then just flip everything.
It doesn't matter?
It matters. We do want milliliters on the top
Oh,
because we want to know how many, if there's X number of milliliters. We don't want X number per milliliter, right? We want milliliters on top. That's what the question, you got to know what the question's asking. So if the milliliters on bottom, because sometimes it happens this way, because I says, well, just start with what you know. Oh, where do I start? One of those that you know. Maybe you started somewhere else, but it was flipped, right? Everything cancels out and you end with milliliters, but it's on bottom. So what do? Just flip everything. This whole thing, just flip it. And now milliliters on top. Is that okay mathematically to do that?
because it's all the same, isn't it?
It's all the same stuff.
Like with the first number, like you also have to flip that, so like put like a 1 over the 140.
That's right. Now, it wouldn't make any sense to flip this one because it worked, right? But do you want me to show you an example? Okay. Let's say we started with what the doctor said, but we used that one instead. So we start with 20 kilograms for every 30 milligrams of drug, right? Let's say we started here because that's a given information. And then we go and say, okay, we don't want kilograms, so let's put kilograms down here. And let's convert it to pounds because we know pounds, right? So 1 kilogram for every 2.2 pounds. And that goes away. Great. Now we don't want pounds. We have a 140-pound person. That goes away, right? Is that okay? Can we just put a 1? Is that okay? Yeah, because the units cancel, right? This is just how.
So like that would be like the one patient, like the patient is 40 pounds, like.
Yeah, we can call this one patient if we want.
So is that like the unit itself then? So
Sure, we can just call it one patient per 140 pounds. That's fine.
and is that gonna be at the end?
It might. Do we want? Maybe we do. We don't just want milliliters. We want milliliters per patient, right? Would that be the same thing? Yeah, right? So, and I'm just doing this as an example because sometimes it might happen, right? You might start it flipped. So we have pounds gone, everything gone. So now let's have milligrams. Okay, so now we're going to do this one right here. But we're going to flip it. 10 milligrams for every 5 milliliters. So this is the situation I was talking about. If you have this, we have patient per milliliters. We don't want that. We want milliliters per patient, right? Then all we have to do is flip this entire thing. Does that make sense? So don't freak out about, oh, I don't know where to start. I don't know where to start. I don't know where to start. Just start with what you know. And if you flipped it on accident, you'll find out in the end. If you include all of your units, and that's the key. Make sure you include all your units. Yeah, Charlie.
So the last step is to take that 140 pounds and multiply it out between the different, but the question is, how do we multiply that?
You mean, how do we flip this thing?
No, not how we flip it, how do we,
Like right here?
yeah, because we have to go 140.
Because that's the wrong one, right? Well,
Yeah.
not wrong, just flip.
Well, not, yeah, but we have to go from 140 to milliliters, so we have to times, or multiply it out between the different fractions.
We do. 140. Do we worry about this one? No, when we divide one, it doesn't do anything. Multiply one. Do we have to worry about that?
No?
No. Can we? Can we just type it on our calculator, multiply one and divide one? It's not going to do anything, right? So you choose the way you want to do it. But so the way I do it, though, just because I like to keep things simple, and it makes sense in my head, if I say something simple but it's not to you, then don't do it that way, okay? So I do 140, divide 2.2 because it's on bottom. This line right here means divide, right? And then multiply, here's the multiply symbol, by 30, divided by 20, multiply 5, divided by 10, equals.
Oh, okay.
You just type it in one time, one equal sign.
Oh, okay.
Multiply by the guys on top, divide by the guys on bottom.
What was
And you're
tripping
done.
me up is I was multiplying it no matter if it was on the top or the bottom, so knowing that if it's on the bottom, divide it, if it's on the top.
Does it make sense why we do that?
Yes.
Okay, good. Did that help?
Yeah.
And this problem could be as complicated or as simple, and it's all the same. If it's simple, there's going to be less of these, right? There's going to be less factors. If it's more complicated, there's more of them. But you just do it until all the units cancel except for what you're looking for. That's it. When I say that's it, I'm not saying it's easy. I'm saying that's all you got to do.
It's not easy, but it has steps. It has a specific way that it can be done.
All right.
It's possible.
Are we good? Did that make sense? Okay, moving on. Okay, what other questions we have? So that was going to help you for the midterm, not necessarily for Unit 2 test. Do we have any questions for Unit 2 or the midterm? Doesn't matter. I'm here for you. But we are going to meet on Tuesday and go over for the midterm, yeah?
So one of the questions on the study guide is, you know that X, X, A, Z, C?
Like this?
Yes.
Okay.
So first of all, is A the total amount of things in the nucleus, like protons and neutrons?
Yep, that's right. Protons plus neutrons.
So then
Whoops,
Z
that's a
must
minus.
be
It's a zero.
neutrons.
Z is what? Number of protons. That's the atomic number. So we find the atomic number right on the periodic table. We could just, there it is. So if we're given that, but not this, well, we just look up this element and we know what the atomic number is and just write it there. Or if we're given this, but not that, well, we can find out what it is.
Yeah.
Make sense? And what is the C?
Electrons.
Not quite. That's the charge.
Oh.
And how do we find the charge? The charge of the protons plus the charge of the electrons, right?
Yeah.
If this is a 1 plus, that tells us we have what? More protons or electrons?
Protons.
More protons. How many more?
One.
One more. And if this is 10 right here,
That means we have 11 protons and,
no, we have 10 protons. Does that make sense? We have 10 protons, and we have one more proton than we have electrons.
9 electrons.
9 electrons. And another way to do this, if that screws up in your brain, you say, I don't understand that. Then, well, we can just make an equation. The charge of the protons, we got 10 protons. That's plus 10. Plus the charge of the electrons. I don't know what that is. I'll call that x. What does it equal? Oh, positive 1. Right? So let's subtract 10 to both sides. And we got x, the charge of the protons, is negative 9. Well, why is it negative? Because electrons are negative. So there's 9 of them. Whoops. Does that make sense? So I'm not saying that do it with an equation, but if that makes more sense to you, do it that way. Okay? Other questions? So let me just tell you right here. On the midterm anyway, can't remember on the Unit 2 test, but on the midterm, it asks specifically what A is. Okay? So you got to remember A is the mass number. I don't like that question, but that's what it is. Okay? I don't want you to memorize A, Z, and C, and X, but I do want you to know what goes here. That's the mass number. What goes here? That's the atomic number. What goes here? That's the charge. And what's this? That's the element symbol. Okay? Are we good? But that specific question is on the midterm. Okay? Anything else?
I think I might have something. I just wrote it down on my phone.
Okay.
Do we need to know the boiling point of molecules? Is there a way to figure it out?
No. All we do with that is we're just comparing.
Oh, well,
Which one is less, which one is more. And how do we tell?
the reference chart we have where it's like ion, hydrogen bonding, dipole.
So the intermolecular forces, right?
Yeah, the intermolecular.
That's it.
Yeah.
Mm-hmm. Yep, that's it.
They have too many syllables in these words.
Any other questions? All right. So I looked through the grades, and it looked like only one of you done the practice test. So is that why we don't have any questions?
Well, we'll be meeting up again on Tuesday.
We will. But hopefully we can use Tuesday to get ready for that midterm, right? Because the midterm, so like the unit test, you can have within a week to take it, right? But the midterm is on the 27th in class, right? On a piece of paper. I'm going to give you this paper. You're going to do it, and you're going to turn it in before you leave.
I had it on the 25th, but that makes so much more sense.
So 25th is review. 27th is the midterm. Good? Okay. Let's see.
So it says know how to convert temperature from Celsius to Kelvin. I don't think
So
I know.
that's for the midterm, but we can still do that.
Uh-huh.
Okay? So if we have, let's say, Celsius to Kelvin, let's say we have 32 degrees Celsius. And we want to know what that is in Kelvin, right? Well, so what's the same as 0 degrees Celsius? 273 Kelvin. You either have to memorize that or write it on your reference sheet. I mean, for the Unit 2 test, you could just look at your notes, but make sure you're working on that reference sheet and have that ready, because that's all you get for the midterm. Okay? Make sure we have that done.
The reference sheet can be like double-sided.
Yeah, let me show you an example. I saved one from one of my students in my high school, because I teach the same class in high school.
Does the printer in the library do color printing?
I don't know. You'll have to ask them.
Yeah, also has to be printed.
So here's what one of my students did. And this is for the final. But they put everything that they needed on one sheet. Another student did it not quite as good. This one looks pretty good. It's color coded, whatever. Here's one that's really tiny, hard to read, but whatever, works for you. Okay? So, put whatever you want on it. You can have your mom's phone number on there if you want. I don't care. All right, whatever you want.
Have your mom's phone number so you can go, Mom, I don't think I'm gonna pass.
Oh, we're gonna pass, right? Hope we're gonna ace it. I hope.
Or worse, you call to go, Psst, Mom, what's the answer for number 13? Well, I know you can't see it.
Yeah, you probably can't do that. Sorry, I'm trying to log in so I can go to the test to see if we can help you come up with questions. How's that? Come on. It's not working to get in, so, oh, maybe. Yeah, it's not working. Sorry. So let me just go over what I think. Okay, this is just for my brain. All right, so let's naming compounds. So if we have CO2, K2O, H2O, C3H8, and NH4OH. Okay. What is the name of CO2? Who can tell me? Go ahead.
Carbon monoxide?
Close. Carbon di. So what's the very first step in naming compounds?
Find prefixes?
Not quite. What? That's right. Determine if it's covalent or ionic. Right? If you don't know this, then you're just shooting in the dark. Okay? So is that covalent or ionic? Covalent. How do we name covalent compounds? With prefixes. Do we use a prefix if there's just one on the first one? No, we don't. So it's carbon. And what's the prefix for 2? Dioxide. Are we good? Who can tell me the name of that one? K2O. Just potassium oxide, because what type of compound is this? Ionic compound. Do we use prefixes for ionic compounds? We do not. And this is a multiple choice test. All the tests are multiple choice. And guess what some of the responses are going to be, the other options? Dipotassium monoxide. That's going to be one of them. Or maybe potassium 3 oxide. How do you know it's not, or potassium 1 oxide? How do you know it's not potassium 1 oxide?
It has to be a transition metal.
Yeah, this is not a transition metal. Do we know where the transition metals are? Good? So yeah, this one's just potassium oxide. What about that one besides water? What's that called? Dihydrogen monoxide. We use mono for the second one, just not the first one, right? 2 hydrogens. Again, we use the first element as the element name. Hydrogen. And then there's 1 oxygen, monoxide. Good? What about that guy right there? What kind of compound is that? Covalent, so we use prefixes again. Tricarbon octahydride. And that's kind of an icky name, right? So we have a lot of common names. That's called propane, but you don't have to know that. Okay?
Did you give us a reference sheet on that?
Nope. Just know this. Know how to name it this way. And what kind of compound is that? Covalent or ionic? Oh, so happy. Some of you guys are getting this. Why is this ionic? Polyatomic ions. We got ammonium, and hydroxide. So make sure you look at that sheet when you're naming these. So what's the name of this guy? Ammonium hydroxide. That's it. Are we good? Let's see. Let's do another one. So what kind of compound is that? Ionic or covalent? It's ionic because iron is a metal. What kind of metal is it? Transition metal. That means we need to know what? What do you mean the number? Like 26? What's the Roman numeral number? What is that? Yeah? What do we need to know about iron?
We need to know its charge.
Its charge. And how do we find that? This is the way I do it. Who likes it a different way? Who likes to cross these numbers up? If you like to cross them up, do it. Make sure, if you do it that way, you double check. We know what oxygen should be, right? It should be 2 minus. And And since it is 2 minus, this is right, that's right. But what if we had something like this? Lead PbO2. Let's do that. Let's cross these up. This is a 1, so we're going to cross that up here, cross this over here. 2 plus and a 1 minus. Is oxygen a 1 minus ion? It's not. That means this is not right either. So what do we have to do? Multiply everything by 2 to make this one a 2 minus, right? So you got to multiply everything by 2, and that's going to make this a 2 plus, or a 4 plus, right? Come on. 4 plus and 2 minus. So this one's called lead, Roman numeral 4, oxide. And what's this one called?
Iron, Roman number 3.
Iron 3 oxide. Any questions on naming ionic compounds with transition metals? And here's a possible question. Can we do another one?
Sure.
Do you want to do another one?
Yeah.
Okay.
Maybe we can do it where we try it by ourselves and then.
Good idea. By yourself, Vid. Just teasing you. All right, let's do that one. Let's do those two. Do we all understand how to determine how many valence electrons are in the main group elements?
It's the distance they are from.
Yeah, but there's an easy way to tell. The group number, right? I mean, it's good to know why, definitely. Who needs more time? Okay, carry on. You got it? Don't tell me, but you got it? Okay. We'll go over it. Just a minute.
Where is SO on this? Or on the periodic table?
Yeah, that's kind of hard one to find on the periodic table. It's not there.
Oh.
This is the capital letter, this is a capital letter.
Oh.
That means it's 2 elements. If it's 2 elements, where are you going to find it? Polyatomic ion sheet. Good? Do you have that sheet?
I thought I did.
And if you want that on the midterm, make sure you put that, shrink it down, and or write them, handwrite them on there.
Is this it?
Yep.
Wonderful.
Oh, I forgot to show you how to name acids and bases, or acids, guys.
We just differentiate mass paper.
It is on, can I see that? It is on this sheet. Huh. I'm gonna have to, maybe we'll have to do that tonight. Oh, I can't believe I forgot that. That's because I didn't have it in my notes. Uh-oh, I better put that in my notes. So here it says related acids, the name, and then the formula. So if you have this, and it tells you to name it, you just look it up there, right? If it tells you to write the chemical formula, you can look it right there. But I'll show you how to do this. Okay, before we do that, what is SN or CuSO4 called?
Copper 1 sulfate.
What do you guys think? Is it copper 1 sulfate?
Copper 2.
Copper 2? What is it?
I'm gonna stand by copper 2 sulfate.
Are we good with copper 2?
Mhm.
How many coppers are there on this one? There's only 1 right here, yeah? 1 copper. How many sulfates do we have?
1.
Just 1. There's no parentheses, right? So if you decide you want to cross it this way, whoops. If you decide you want to cross it this way, this is going to be a 1 minus, a 1 plus. What's the charge of sulfate? A 2 minus. This is why I don't like to do it that way. It works great when you don't have to do anything else. This is why I like to do it this way. What's the charge of sulfate? I look it up on the polyatomic ion sheet. It's 2 minus. How many sulfates are there?
1.
1, because there's no parentheses. Don't fall into the trap of saying there's 4 of them. There's not 4. So that's a total charge of negative 2. This has to be the same charge but opposite so that it's neutral, right? And there's only 1 copper, so it has to be 2 plus. So it's copper 2 sulfate. Are we good? Question, yeah.
Does it always have to be neutral?
Always. Ionic compounds are always neutral. Are covalent compounds always neutral? Not when they're polyatomic ions. Polyatomic ions are also covalent compounds. There's no metals in any of them. You with me?
So how do you figure out acids from bases?
We'll do that in just a second.
Oh, sorry.
No, you're good. All right. So what about this one? Do you know what that's called?
Tin dioxide.
What?
Tin dioxide.
Tin what?
Terra.
Tin teroxide? How do you know? Because tin's a metal, or is it a non-metal? It's a metal. So this is an ionic compound or covalent compound? Ionic. So do we use prefixes for ionic compounds? Never. Make sure you check that first. Okay, do we know the charge of tin? We do not. Tin and lead, write this in your notes if you have to. Tin and lead are an exception to the main group elements. They are also variable. cations, just like the transition metals. So tin and lead act like transition metals. They're not transition metals, but they have multiple cations. Good?
So they're,
So we have to do that one just like a transition metal one. What's the charge of oxygen? 2 minus. How many oxygens are there? 4 of them. So that's -8. This side has to be +8. So what's the charge of tin?
8?
8 plus, because there's only one tin. So what's this called? Tin Roman numeral 8 oxide. Or we just call it tin 8 oxide. Are we good?
How high up do you think they're gonna go with Roman numerals?
8.
Oh, okay.
Yeah, do you guys know Roman numerals up to 8?
I know up to 5.
Let's do it. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's do 10 just to make sure we got this. 1 is I. 2 is I. 3 is I, or 3 I's, right? 4 is 1 before 5, and 5 is V, right? Are we good? What's 1 after 5? Are we good? Just one more after 5, which is V.
Oh, okay, and then
And
it keeps doing that up till,
7,
and then it keeps
8.
doing that up till
Well,
10.
then 10 is X, so that means 9 is
1.
IX, right? We're good?
I'm gonna copy this down.
Yeah, do it. Any questions about naming compounds besides acids?
So in the tin oxide, the tin didn't have the 4 electrons, the 4 valence electrons.
That's an exception. Tin and lead are exceptions to that rule.
So the tin have the 8 valence electrons.
They have
They charge 8.
multiple, many different, more than one. Kind of like iron, we could have iron 1 plus, and we could have iron 2 plus.
To find them, we always depend upon the other.
It depends on what it's bonded to, yep. Depends on its chemical formula. So we'll always give you either the charge. So if I give you this, can you write the chemical formula to that? Tin is SN, what's the charge? 8 plus, oxygen is O2 minus, then you cross them. SN2O8, is that it? Got to simplify it. SNO4.
So you
Got
can
it
do
all.
forwards and
Questions? We'll go over that a little bit more. It sounds like we need to maybe.
backwards.
If something were to use like a metal weight, like would that be like ionic or?
Yeah, it depends.
Like, you see like when the stairs part, that part.
Yeah, those. You won't need to worry about that really.
Is aluminum a metalloid or just a metal?
Aluminum is a metal.
Okay.
Yep. Okay, before we write chemical formulas, let's name acids real quick. So this is new information. Good?
Mhm.
If you have that polyatomic ion sheet that I gave you, they're all on there. So, but I'm going to just tell you, because they might tell you what's the oxy acid or what's the binary acid. There's 2 types. Well, I guess the binary acids aren't on there, so we better do this. So binary acids. and oxyacids. Do you guys remember? Well, let's do one at a time. Binary first. What does bi mean?
Two.
Means two, right? Kind of like bicycle. So that means there's two elements in this acid. How do we know it's an acid? If hydrogen is the cation for it. So this acids are ionic compounds, even though they don't have metals in them. Okay? So if hydrogen is the cation, meaning in front, then it's an acid. So if we have hydrogen with, let's say, fluorine, HF, we call this hydrofluoric yes. I'm running out of room. Hydrofluoric acid. So for binary acids, we use hydro as the prefix. Then we change the ending of the anion to IC, and then we add the word acid. So what is this called?
Hydrochloric acid.
Hydro. This is only two of them, so this is binary, right? Hydro. We change the ending to IC, chloric acid. Make sense? What about HBr? What's that called, everybody? Hydrobromic acid. And what about HI?
Hydroiodinic acid.
We change the ending to iodine to ic.
Iodic acid.
Uh-oh. Iodic. We always get that one, sorry. Iodic acid. Are we good? I'm glad you're laughing. Okay. So those are the only binary acids that there are. Well, that we use in this class anyway. Okay. So oxyacids, do you guys remember what an oxyion is?
It contains oxygen.
It's a polyatomic ion that contains oxygen. Okay? And so here we go. If we have H2SO4, we do not use hydro. Do not use hydro for the prefix, okay? So we're still going to change the ending to IC if, so there's two rules here. If the oxyanion ends in ATE, then change ending to IC. If oxyanion ends in ITE, then change ending to OUS. So what's H2SO4 called?
Sulfuric acid.
SO4 is a polyatomic ion called what? What's SO4 called? Look at your sulfate, right? It ends in ATE, that means we gotta change the ATE to IC and call it sulfuric acid. Are we good? And the reason we put this in here, because it'd be sulfic acid, and that doesn't sound like sulfur much, okay? What about HNO2? What is NO2 called? Look on your list.
Nitrous acid.
What is NO2 called?
Nitrite.
Nitrite. So what's this called? Change the ending to,
Nitric acid.
if it ends in ITE, we better end the acid in OUS.
Nitrous.
Nitrous acid. But we don't use hydro for these. That's the difference. Are we good?
Just let me copy some stuff down real quick.
So all of the oxyacids are on that reference sheet. And if you have it on if you have that on your reference sheet, you can use it for the midterm. If you don't, you have to know how to name them. But the binary acids are not. But there's only 4 of them. Hydrofluoric, hydrochloric, hydroiodic, hydrobromic.
Midterm, chapter 2.
Midterm is on unit 1 and unit 2.
Will it be on the midterm?
Uh-huh.
Sure.
It's on unit 2 test too. Yep. Any questions?
So we find it using, or we find what it ends, like sulfur, it ended with 8, or sulfate.
Well, you look at the polyatomic ion list and you find, so this is said H2SO4, so we find SO4 on here. SO4 is right here. And what's that called?
Sulfate.
Sulfate. Since it ends in ATE, the acid's gonna end in IC. But if we have like NO2 minus, this is nitrite, it's going to be nitrous acid.
Versus nitrate, which would then become nitric.
That's right.
Wonderful.
Now, what? It's just a naming system so that we can tell them apart. That's all it is. Are we good with naming acids? Any questions? Here's a possible questions. Can we do more for examples?
Sure, yeah.
Okay. So what about what's that one called? Look at your sheet. Look at your reference sheet. Anybody? Go ahead.
Carbonic acid.
Carbonic acid.
Carbonic acid is right. Questions? So this is carbonate. Change the 8 to ic. Carbonic acid done.
So, hydroiodonic, hydrobromonic, like, all of those are like the only exceptions.
Hydrobromic. These aren't exceptions. These are binary. There's only 2 elements in these ones.
Oh, okay. But like, so if you paired a hydrogen with any other element, it would go by the oxygen,ids, not binary acids.
No, you wouldn't have it.
Oh,
It wouldn't make it.
okay. It just wouldn't exist.
That's right.
Mm.
Well, as we know it today.
Who knows, maybe somebody will invent it tomorrow.
I don't think there's such thing as inventing science. Maybe discovering it. Just kidding. All right. But yeah, maybe. Let's do one more. Can you write the chemical formula for that? Phosphoric acid? See if you can do this. Write the chemical formula for phosphoric acid. Anybody have it? Go ahead. H3PO4. Does everybody understand how we got that? So, since it's an acid, what's the cation? H plus is the cation, right? Since it's phosphoric, what's the anion? Phosphate, right? So PO4, 3 minus. Then we just do it like all ionic compounds. Cross this 3 down here, the 1 down here, and we got H3PO4. And we don't need to write the 1, so we're good. Does that make sense to everybody? All right. Are we good with acids? All right. Do we want to write chemical formulas now? Okay. So writing chemical formulas, let's do, if we have zinc 2 sulfate. What is the chemical formula for zinc 2 sulfate? ZSO4? Look at your periodic table, don't guess. What's the symbol for zinc? Zn. Zn 2 plus. Show your work and you'll always get these right. If you don't show your work, you might mess up. SO4 2 minus by looking at our chart, right? It's a 1-to-1 ratio, we can see that, or 2-to-2 ratio, right? You need 1 positive 2, 1 negative 2, makes it neutral. Or you can cross them and simplify, right? So it's just going to be ZnSO4. Good? Okay, what about sulfur dioxide? What's that? What's the chemical formula for sulfur dioxide? What kind of compound is this? Ionic or covalent? How do we know it's covalent? because it has prefixes. And because there's no metals, right? Who's got this? SO2, right? Are we good?
Can we do one where it's like a try it on your own?
Yeah. Let's do... strontium nitride. You having a hard time finding strontium? This is why it's good to become familiar with the elements on the periodic table. But if you have to, look at one at a time. Just keep looking through them slowly, slow down. Because if we just race our eyes, we're going to miss it and miss it and miss it, right? Okay. Who can tell me what the chemical formula for strontium nitride is? Strontium nitride. That's it. Because strontium is 2 plus, nitride is 3 minus. Cross the numbers. It's a 3-to-2 ratio. We can't simplify it, so we're good. Good? Do we have any other questions on writing chemical formulas?
The sulfur dioxide,
What?
the sulfur dioxide, the sulfur have 2 positive and no, it's 2 negative.
This is what kind of compound?
Oh,
Covalent. Do we deal with charges on covalent?
no.
No. No charges. Only charges are only for ionic compounds. Why? Ions are charged particles. Are we good? So we use ionic compounds. Make sense? I'm glad you asked. Perfect. Good? All right, so let me go through my notes and you tell me if you need help with this stuff. Do we know how to find the ion symbol? We've been doing that for this, right? Are we good with that?
It's when you compare the electronegativities, right? Or I'm thinking of...
No, I'm just saying find the symbol O2 minus,
Oh, yeah.
right? We good? We know how to find O2 minus. We're good with that? Okay, cations and anions. What about the octet rule and valence electrons? Counting valence electrons. Good with those? Some of the basic things we've done. So we talked about all that. Writing chemical formulas. Do that for transition metals. Polyatomic ions. So make sure you have that sheet with you. I think we're good there. Okay, yeah. And that. Okay, Lewis structures. Do we need to go over Lewis structures? No? Okay. What about molecular geometry or electron geometry?
So with molecular and electron geometry, if you've got something like a, hold on, let me draw it for you. I don't know how to, well, I guess 3 carbons and 6 hydrogens. If you've got something like that, what is the geometry of it?
Let's do that instead,
Okay.
because the other one doesn't exist.
Ah,
Well, which one's the central atom? Never hydrogen, so it's going to be carbon. There's 3 carbons, and there's 8 oxygens. 1, 2, 3, 4, 5, 6, 7, 8.
so what is the molecular geometry called?
Well, what's the central atom?
Carbon?
Carbon. There it is. Oh, or could you pick this one? Or could you pick this one? Doesn't matter. How many regions do we have? 4 on all of them. They're all the same in this case. It's what? What's 4 regions called? What? 4 is tetrahedral.
Tetrahedral? Okay.
Good?
Tetrahedral.
Anything else on molecular geometry? What
And also with the ions.
What?
You give
Oh, the polyatomic ion?
the element and how to find that and ion from that. Like give the X element and have the ion from that and how to find that.
So if I give you, oh yeah. So let's say we have X, X2O3, and the X ion, you mean like this? The X ion has, let's say, 10 electrons. What is X? Yeah, this will be on the test and the midterm.
So it's,
We're looking, X is not on the periodic table, so we have to find out what X is, right?
Aluminum.
Aluminium?
wait, no, wouldn't it be neon?
Is it neon? Let's find out. So oxygen has a charge of what? First, we got to know the charge of that guy. We don't even know what element it is, so there's no way of knowing, right? So we use what we know, start with what we know. 2 negative, how many oxygens are there? 3 of them, so that's 2 times, negative 2 times 3 is negative 6. This side has to be
Positive.
positive 6, and there's 2 of them. Divide positive 6 into 2, that's 3 plus. Okay. So X3 plus has 10 electrons. How many electrons does X have? Before it became 3 positive, what does it mean when it became 3 positive? Did it lose electrons or gain electrons?
It just loses.
It lost. How many? 3. And then it has 10. So how many did it have before it lost 3? 13. So if it has if the neutral element has 13 electrons, how many protons does it have?
13.
Also 13. So what element has 13 protons?
Aluminum.
Aluminum. Good? So go through each step, all the steps. Don't just say, oh, it has 10, so it's neon, right? Go through all the steps. Any other questions? What about polarity? Can you determine if a compound is polar or not? Who has questions? Anybody have questions on determining if a molecule is a polar molecule or a non-polar molecule? Good? Okay. And then intermolecular forces. Any questions on intermolecular forces? And how to tell which one has a greater melting point or boiling point? Any questions on that?
So ionic is the one with the highest boiling point
Because it has the strongest intermolecular force.
oh, okay.
Remember, the intermolecular force is the force that's holding the molecules together. Otherwise, it's a gas. So gases don't really have intermolecular forces because they're so far apart, right? They're just spread out. So there's not really an intermolecular force for gases, but for liquids and solids, they're held a lot closer. And that's why liquid, you don't see individual atoms, it's just all together, right?
Yeah.
And solids, same thing, it's all together.
So,
So the intermolecular force holds them together, and the melting point, once you melt it,
breaks
it
down.
kind of breaks them apart. And as you boil it, it even breaks them apart further, right? So if it has a stronger intermolecular force, it has a higher melting point or boiling point.
And then,
I didn't really explain that, but that's why.
and then they vaporize and go up into the air at like a, well,
If it turns into a gas,
Yeah.
and then there's no intermolecular force.
So is that how you could take something like water and get oxygen, or not maybe oxygen out of it?
So let me say this one more time. If we have water, this right here is a chemical bond. And the only way to break it is by a chemical reaction. But if we have two water molecules, then we have this other attractive, it's not a bond, this right here is the intermolecular force.
Oh, okay. So you
And so when you melt it or boil it, it doesn't break this bond, it just takes that away. And so it makes them further apart, and now it's gas.
So you can't take the hydrogen out of it, but you can change its state from like frozen to liquid to gas.
That's right. Good? Any other questions? Are we done then? So, before you take the test, Unit 2 test, take the practice test. And if you have any questions, email me. Because the practice test is harder than the real test. So if you can do the practice test, if you get it, then we're golden. Okay. Are we all going to be here on Tuesday?
Yep.
Okay. Come with questions. So is there a practice test for the midterm? There's not. Go through the practice test for Unit 1 again and Unit 2. Or just when you're taking the Unit 2 test, take notes, right? If you have questions, bring them in. If you get 100%, good job.